Welcome to the Student the Brand. This is your Shiva sir. Today topic is motion in a straight line. So in motion in a straight line, we are talking about so motion. First of all, motion. What is motion? The object moves from one place to another place with respect to time. Then we can say object is in motion. So if you are considering rest, if the object does not move with respect to time, if the body stays at the same place, then we can say object is at rest. So even though the time passing, the object does not move, then we can say object is at rest. So when we can say object is in motion, object moves with respect to time. Okay. So here there are types of motions: one dimensional motion, two dimensional motion, three dimensional motion. One dimensional motion means object moves in a straight line, in a linear path. Then we can say object is in motion. If object is in two dimensional means x axis, y axis. So with respect to x axis and y axis, if you consider, then the object is in three dimensional motion, two dimensional motion. If x, y, z, x, y, z. If you take in three axes, then we can say object is in three dimensional motion. I hope it is clear. One dimensional motion means object moves in a straight line path. Two dimensional motion means object moves with respect to x axis and y axis. So coordinate axis. Three dimensional means object moves x axis, y axis, and z axis also. Then we can say object moves in a three dimensional motion. If one dimensional motion means, so best example, a car is moving on the ground, a bus is moving on the ground, a cycle is moving on the ground, say a motorbike moving on the ground. So like this, a straight path. So if it is moving like this, so two dimensional motion. So along with x axis and y axis, we can say. Okay. So then next one. Frame of reference. What is a frame of reference? Frame of reference is nothing but with the uh, background point with that, so on fixed point with that all observations are made. So that is called frame of reference. With respect to one point, then all things will be observed. Then we can say frame of reference. Then we can consider the path. Path is nothing but the line joining of successive points. So I am taking one point here, one point there, like that. So if you are joining all the points, then we can say path. Then we can say path. So we can consider distance. The length of the path is called distance. Length of the path is called distance. Okay, length of the path. And displacement. The shortest path from initial point to final point is called displacement. So distance can be taken. Okay, any direction we can consider distance. So if I'm taking from here to here, from one point to another point, we can go in many directions, but whereas the displacement, we have to take shortest path, from initial point to final point. That is called displacement. And coming to speed, speed is nothing but total distance traveled by an object per unit time. Total distance traveled by an object per unit time is called speed. Speed is a scalar quantity. It has only magnitude. It doesn't have any direction. It has only magnitude. Speed has only magnitude. So distance by time taken. We can consider distance by time taken. Okay, so that is called speed. SI unit of speed is meter per second. SI unit of speed is meter per second. Clear? Okay, next. And here dimension formula is m power 0 L power 1 T power minus 1. M power 0 L power 1 T power minus 1. T power minus 1. That is dimension formula. So coming to the uniform speed. Uniform speed means total distance covered per total time taken. So that we can consider an object covers equal distance in equal interval of time. So equal distance, if the body covers equal distance in equal interval of time, that is called uniform speed. Non-uniform speed means unequal distance in equal interval of time, or equal distance unequal interval of time. So two types we can say: Uniform speed means equal distance, equal interval of time. Unequal non-uniform speed means unequal distance in equal interval of time. Equal distance, unequal distance, equal interval of time. Unequal distance, equal interval of time. Equal distance, unequal interval of time. That also we can say. So that is non-uniform speed. Okay. So that's enough. Next, we'll go with the next one. So what we can say? We'll go with the one more average speed. Total distance by total time taken is called average speed. Okay, instantaneous speed. Here is a one point. If suddenly the object moves at that particular point. What is speed of the object? That is called instantaneous speed. Instantaneous speed. And velocity. What is the velocity? What is velocity? Displacement by time taken. Displacement by time taken. That is velocity. And what is the SI unit of velocity? Meter per second. What is it? It's a vector quantity, scalar quantity, vector quantity. Because it has both magnitude and direction. It has both magnitude and direction. That's why it is a vector quantity. And so vector can be positive, negative, and zero. Even acceleration also, if you take acceleration also, if you consider acceleration positive, negative, and zero also, because it is a vector quantity, right? And displacement also we are considering. The average velocity equal to nothing but total displacement to total time taken. Instantaneous velocity, instantaneous acceleration, instantaneous speed, anything you take instantaneous means at that particular point the acceleration of the body is called instant acceleration. And that's enough. That is about acceleration. If you take acceleration means nothing but change in velocity by time taken. Acceleration is a vector quantity. Acceleration vector or scalar vector quantity, right? So SI unit of acceleration is meter per second square. And dimension formula is m power 0, L power 1, T power minus 2. Because it is, there is no mass, but length is there. Meter per second square, they think. Okay. Next, uniform acceleration, non-uniform acceleration, and uniform motion graphs. Graphs we can say, graphs we are taking next, and velocity time graph. So here formulas are there. S equal to ut plus half a t square, v square minus u square equal to as, v equal to u plus 80. These are the formulas. So those formulas are very important. And yes, Sn equal to u plus a by 2 into 2n minus 1. That also we can consider. And next one, equation motions. These equation motions will change according to the uniform, according to the free body diagram, means freely falling body, and vertically projected body. It depends on two cases. Freely falling body, when the body is moving freely, if the body is dropping freely, that time initial velocity is 0, acceleration is positive. Whereas if the body is throwing upward direction, that time final velocity becomes 0, because it's reaching to the max height. At max height, final velocity becomes 0. Final velocity becomes 0. Acceleration is negative. Acceleration is negative. Okay. So that's enough. That is about. And here, based on the okay, so positions, based on the position, the velocity, displacement, positions also will changes. And if from starting onwards, so the length, we can take a distance, displacement, speed, velocity, acceleration, uniform, non-uniform, average, instantaneous. In all the three cases, this we are using. And one more thing we can go with that. So one more point we can consider equation of motions. Equation of motion S equal to ut plus half it square, v equal to u plus 80, v square minus u square equal to s. So this formula is also very important. So this is about today class. So we'll see in the next class. If you have any doubts, so we will work out on it. So make sure that whatever we are discussing, what are the points we are working on it, so you can recall all the points once practice on the paper, then you'll get it. So remaining will come with a new chapter. So motion in straight line and remaining chapters also available. Those chapters we'll discuss. Until then, bye bye. See you. Thank you.